All right, so I'm Mitch. I'm an architect here in Federal, and I'm going to be demonstrating Cisco Care, which is Cisco Audit and Remediation Engine. It is a package that we built upon NSO. So all the power you see and you just saw with NSO, it's like an add-on package to that. And the goal here of Care is to automate the stigging of devices. So we automate the validation and remediation of devices for DISA STIGs. And so the goal, the end goal is really to reduce the time it takes to remediate devices going through your STIG process, right? So if anybody has ever STIGged by hand, you'll know that it's very painful, it's time consuming. And so the goal here is really to reduce that time by orders of magnitude. I'll also mention, and Tim's going to talk about this, their testing methodology that we do here. We really reduce, I think, the human error. You know, humans, when you're going through your STIG process, we get tired, we make mistakes, right? And so if we look at this as kind of infrastructure as code, we can test our code and we can, I think we have a great level of assurance that what DISA publishes for their STIGs, you know, we can meet with a high degree of confidence. And of course, the end goal is to really reduce the workload on getting through your CCRIs and getting to your ATOs, right? And so I think we do that. I think we built something really cool here. And so that's what Care is, and that's the goal. So I'm going to roll right to the demo. Okay, so I'm going to go through a couple things that are kind of behind the scenes things that allow this all to work. So the first thing is the findings catalog. So the findings catalog, we ingest all this data directly from DISA into NSO, into the data model. So if you look at any of these particular vulnerability IDs, and you know anything about what DISA publishes, all these fields, these are in the Yang model, right? And they line up directly with what DISA publishes. So it's very easy to, it's very simple for us. It's a single stage process that ingests data from DISA into NSO, into Care. Okay, and so in that respect, we are able to stay in sync with DISA very simply, right? So when they publish new STIGs or make modifications to their STIGs, make modifications to their STIGs, we ingest it directly into Care, into the Yang data model. And then we use this data as output, as you'll see later on. Okay, so that's the first thing, is the findings catalog. Now, again, that's nothing that an operator who's running Care has to worry about, but I just want to give you some background. Okay, the second thing is the STIG catalog. So what you see here is the STIGs that we currently support. And so if you're familiar with DISA STIGs, hopefully you'll recognize these. This is classic iOS, iOS XE, iOS XR, and NXOS for NDM, RTR, and L2S. So we basically support the gamut of Cisco router and switch platforms currently. Okay, so we basically cover basically all Cisco routing and switching platforms for DISA STIGs. And if you look at these, this is not something that an operator has to worry about, but just as a background, this is basically the mapping of the vulnerability IDs to the STIG IDs, which are not one-to-one mappings, right? We have multiple vulnerabilities going to STIG IDs. And so this is the mapping that does that kind of translation for you. Okay. As an operator, the first thing you basically have to do is we give you something called site library, which are all the templates of all this DISA STIGs. Okay, so the first thing you basically do as an operator or administrator of Care is that you take one of these templates and you make a copy, and it's a single command. Make a copy of one of the templates for use in your particular environment. So you take the templates, you make a copy, and then they will show up here in site operations, which I just have a couple of. Okay, so In this case, I have router XE and DM, right? And this is where you have to actually fill in some variables to run care. So the first thing you have to do is you have to add your devices. So in this case, I have only a single device for this demo, but this is where you would go ahead and add your routers and switches as appropriate. And, I just had called it test, but this would be something relevant for you guys, for an operator or administrator. It would be something like, router and DM WAN edge, or, L2S access layer switches, something like that. Something that's relevant for how you guys actually STIG your devices. And so we add our devices, or you can add a device group. So this is an NSO construct that allows you to group multiple devices. So you can group, all your access layer switches and building 100 together. And then you can actually add, I think I just have one. I won't add that as a demo. You can just add them here. So that allows you to group all your devices very simply in a single command. Okay. And then the next thing after you add devices is that you actually have to add some local variables and make some modifications here. So if I look at this, there's a couple fields I want to highlight. The first is the status. So by default, all the vulnerability IDs are active. Okay, meaning it's going to include this in the STIG run. So if it's not active, if you want to change it to something like not applicable, if you know it's not applicable, a priori, you can set that. If you have a waiver for that particular vulnerability, you can set it here. Or if you need, a human needs to go out and interrogate that particular vulnerability ID, you can do that here. And so those three things basically, it basically skips over that particular vulnerability ID in the run. Okay. The second thing that you've got to potentially fill out is local variables. So you'll see that most of these in this case are false, meaning there is no local variable here, but let me find one. So here in this particular vulnerability, you have to add the addresses of your NTP servers. And so this is where you have to go in, you click, and you just put in the address of your NTP servers, right? Fill in those variables, and you're done. And so you can see there's just a few local variables that you need to do before you set up your STIG run. Okay, and the final thing is the auto fix, and I'll get back to that in a second, but just hold on to that. Okay, so before I actually demonstrate the full run, we have this handy little tool called Run STIG ID. And what I can do is I can run a single STIG ID or vulnerability ID against a single device. And the operations that I can do, and the operations you can do in care, are three. You can do a print, you can do a check, which validates that you're meeting the STIG, or you can do a fix, which actually remediates, goes out and pushes STIG configuration where possible to that device. Okay, so in this case, let me grab STIG, change that. So this is, just highlight this. So this is ND0010, which says max connections must be 2 and SSH parameters. All right, so if I look at that, so in this case, it is 2, and it looks like these parameters are correct for the STIG. And if I, oops, 2. Vincent. And so if I do a check, it should pass, right? And now let me go in and actually change that. So I modify the configuration, right? So if I go IP, HTTP, max 7, and go back here, and now this is one of the cool things I think about NSO is that if you've never seen this before, I think this is a very powerful feature that you get out of the gate from NSO, and that is that so NSO maintains state. It maintains state of all your infrastructure once you onboard your devices. So in this case, it's telling you that what is in CDB, configuration database, is out of sync with the actual device, okay? And if I do a compare config, it's going to tell me that, hey, max connections used to be 2, right? This minus sign, and now it's 7, right? So it's a very simple way to maintain state and view. So if you have, a baseline config that you want to maintain, or some kind of golden configuration that you want to maintain, NSO, of course, gives you the ability to very simply know if there's configuration drift. Okay, and you can effectively return to baseline, right, by doing a sync to. In this case, I'm going to do a sync from, meaning I'm going to accept that configuration into the database for the demonstration purposes. And so now if I go back and I do a run STIG ID and I do a print, of course it's 7, and if I do a check, it's going to fail. And the failure message, so whenever possible with care, we are going to give you the exact configuration that should be on the device. Okay, so in this case, of course, it should be 2, and so you can actually go in and just paste that into the device if you're doing it, by hand, or in this case, you can do a fix. Now, let me just make sure that there's no smoke and mirrors here. All right, we know it's 7, and if I go in and do a fix, it'll apply that as a fix and change that back to 2, hopefully. And if I do a print, it's back to 2. And if I do a check, it passes. And if I look here, it's back to 2. So the 3 operations that we give you out of the gate are print, check, and fix. Okay, now, not all vulnerability IDs are we able to fix or remediate. And that is shown here in this field called autofix, which is just an indicator of the vulnerability IDs that we're able to automatically fix. Now, you'll see that some of them are false. Now, what's the rate? Somewhere between 60 and 80% of all vulnerability IDs we are able to fix automatically, okay, or remediate automatically. Now, why is it not 100%? We don't do anything that will lock you out of the device, or we don't disrupt any control plane or data plane operations. So we don't go in and modify ACLs. We don't modify BGP passwords. So we're not going to do anything that's going to disrupt operations of the network or the ability to get into the devices themselves. And so that's why it's 60 to 80%. Okay, and so this is just an indicator of what we're able to automatically remediate and not. Okay, so now we can do a run care. So in this case, I had just run this, but I'll do it again. So in this case, I'm choosing that NDM template, and this is a check. And so it's going to go out and validate the full set of NDM STIG IDs against that particular device. Now, you could have multiple devices, of course. Now, one thing I'll mention is that we're not actually going out and interrogating the device, right? This is running against CDB. So it's running locally against the database. And so the side effect of that is that, or the effect of that is that we can scale very well, right? We can scale linearly because we're not going out, if you have 1,000 devices that you're going out to run STIGs against, we're not going out and logging in, to one, checking it, logging out, and logging back in. We're just running it locally against CDB. So that allows us to scale, right? Okay, so this is a snapshot of the output. It's router NDM, it's a check. There's 51 active, which is all of them. We don't have any waivers or not applicable device. And then the overall status is fail. And that's because we have more than one failure. So in this case, we have 25 that passed and 26 that failed. Okay. And I also mentioned the device is in sync. If it's not in sync, you will get an error message, or you can actually set it up to sync the device before you do the STIG run. Okay, so this is the snapshot of that particular run. Let me get to oops, the reports that we actually generate and the output that we generate. Okay, so we give you basically three outputs that are important. The first is the full report. Okay, so in this case, we give you some details about what the STIG is, what the list of devices are for that particular STIG. We give you all the local variables that I mentioned. In this case, I didn't fill any out, and that probably caused some failures or some errors. And then we give you some information about the device itself, right, or a set of devices if you have more than one. And then we just go through and we go through each of the particular vulnerability IDs for that particular device. So we're starting with our first device, and you'll see the first one is a pass. So this is ND0010. This is a pass. And we just go through and we rummage through all of these guys. And you can see it's a pass, so there's no configuration change required. And so now we get to our first failure. So in this case, we're not able to, there was no ACL on the VTY interface, right? So we're not able to give you the configuration exactly. We just give you an error message. Okay, so that's the first thing. We're either going to give you an error message. Hopefully it's meaningful. Certainly if you look at the STIGs, you know the STIGs, it should be meaningful. So that's the first case. The second case is we actually give you the CLI that should be on that device, right? So here we have a fail. This is what should be on the device. And here's another one. This is a fail. There's no banner on that device, right? So that's a finding. Okay, so and it just goes through all of these, right, one by one. And then if you have multiple devices, it would just tack them on at the end. And if I look here, it took 14 seconds for that run, and that's about average. Somewhere between 5 and 20 seconds is typical on a per device basis. So certainly, our goal is sub 30 seconds on a per device basis, which hopefully is a lot quicker than having to do any of the stigging that you do by hand, right? Okay, so that's the first piece of output. Is the full report. The second one I want to highlight is the checklist, and this is probably the most important for people actually going through their CCRIs. Okay, so the second thing we do is we give you the checklist file itself, and so you go through and you simply import the file from checklist from file, right? And this is the exact checklist that you would normally get when you do that through the STIG viewer. And so in this case, we fill in some data here. So we tell you that in the finding details that the output is from care. In this case, it's a pass. And then we give you the details about that particular vulnerability ID. Let me change this. Okay. And so you can see that all these guys are passes, and then we get to our first fail. Again, it's a fail here. We show you what the error message is. This one, in this case, we give you the actual CLI. So you can go in and you can fix that, fix it through care, or you can do it manually, right? And then you simply, if you did it manually, you can add a comment, and then, you can change this to not a finding, right? And so that's the second piece of information piece of data that we give you. The third one is, and this is the same that you would get through the STIG viewer, is the CSV file. So again, we give you all the information on that particular STIG run for that device or set of devices. And so I think we give you, everything you guys need as artifacts for your RMF package to get through your CCRIs. Okay. How am I doing on time? All right. So that's an overview of care, and that's basically our 1.0 shipping release. Okay. Now, what we have on the roadmap is something I think really is the holy grail of how we go through our stigging process. And so the problem is, of course, if you go through your CCRIs and you pass and the auditors go away, you submit your package, whatever, And then you log into a device and you make a change. Are you still stigged or not? And the question is, the answer is you really don't know. And so where we're going to, and this is kind of our 2.0 release that's we're working on, is a fully closed loop, no human in the middle model where, again, NSO knows if the configuration on the device changed. And so with that, right, we can trigger a care run, which goes out and reruns care and gets that data back, and then we can present it in a very simple, easy to look at, easy to consume interface where you know the compliance state of your network. And so this is a mock-up, right? But I think you get the idea. The idea is that you have 10 non-compliant devices. You can click on that. That'll give you the list of the devices. You can click on the first router or whatever. Go in there. You can see the failed vulnerability IDs and do something about that. Make your changes, and then it will automatically rerun care for you and update this interface. And so really a kind of a true continuous compliance, closed loop system that with a simple interface so that we can, the compliance state at any given time, right? So if you're looking at your pre-CCRIs, you kind of know how much effort you have to get through your CCRIs. And so that's where we're going. And I think that really that's the holy grail. If we can solve this problem, I think it'll make things much, much simpler for getting through your CCRIs. Okay. I think that's all I have to share. Tim is going to talk about kind of the methodology we have for testing all of our code.